message, right? So these are the 4 components that we have in SOA, right? So now we are going to cover one last topic before we move to the principles and the discussion related to service orientation principles. And that topic is interrelation diagram. Interrelation diagram as well as definition diagram of SOA components. So there are 2 topics. I'll be covering both of them together because they are related, right? So definitely the components which we have just defined are related to each other, right? So we'll start with that and then we'll see which component can define the other. So just like a chain rule, right? This component defines the next one, this component defines the next one, and so on, right? So based on that, we have 2 diagrams. But before we go for the diagrams, I'll cover the introduction to those diagrams first, right? So the first concept that is written over here is an operation sends and receives the messages to perform the work, right? An operation sends and receives the messages, right? So can I say that operation and messages are directly related to each other? Or can I say that operation includes the messages? Would that be correct? Yes, right? Okay, thank you, Prince, for the reply. So that is one part, right? Operation and messages are closely related, we can say that. Another aspect of this statement is, can I say that operation defines the set of messages, right? Or you can say the reverse. Operation is defined by the messages it processes. So which one is correct? I'll repeat the statement. An operation defines the messages or operation is defined by the messages. Which one would be correct? Over here you can see only one statement, right? And obviously that is true. That's correct, right? Because it is the message exchange pattern that will decide your operation, right? Do you agree to this? The message exchange pattern defined by the messages will define your operation, right? So the second statement is true, as I said, right? So if you are asked true or false anywhere, you should know this, right? Okay. Next is a service group's collection of related operations, right? We have seen this. Operation is a collection of, or you can say container of messages. Similarly, a service, if you go one layer upward, service is a group of related operations, right? So we can say that a service is therefore mostly defined by the service, by the operations, right? Because if you look at the operation names, can you identify the name of the service by looking at the list of operations? You have drawn UML diagrams, right, for your projects as well as in earlier labs, right? So if you have defined the signature of your methods, would that be easy to guess the class name if you are not knowing that? Yes or no? I'm talking about object-oriented programming, right? If I know that the method names are add employee, get employee, update employee, and delete employee, right? Obviously, what would be the name of the class? Employee manager, right? So in that sense, we can say that service is a group of, or you can say collection of related operations, right? And you can also see the definition over here. Service is mostly defined by the operation, right? Why we say mostly? Because sometimes if you are defining an operation which is not giving you any idea that this operation belongs to this class or not, right? Sometimes it may happen. So if the naming convention is important, right? How you name your operation, right? So that you can easily guess what is your class name, right? Okay. Then comes process, right? Now, as we have seen in the week before, process is a static definition, right? In process, we define the rules that under this situation, this set of services will be called, right? We might be defining a flowchart kind of logic. Remember that, right? Process is nothing but your logic of orchestration, right? You are defining it statically, right, at design time, right? So if I take an instance out of that, right, at one point of time, what services will be called? That is called a process instance, right? So a given process instance can compose services, right? But the main point is process instance is not necessarily defined by its services. Why? Can you tell me why? Can you understand the statement which is given over here? Because it may require only subset of functionality offered by the services. Okay. Let me clear out that difference, Priyank. I think we need to refresh that. So process is a static definition while activity is a dynamic execution scenario, right? So at runtime, when the services execute, right, that is called an activity, right? While process is defined in the logic, in the core, right? So it is a difference between static versus dynamic, right? Yes. Okay. So what I'm discussing over here is process instance is not always defined by its service, right? We have up to this, what we have understood? Messages define operations, right? And operation defines services. Are you all clear with these 2 points? Messages define operations and operations define services. Is that fine to all? Yeah. But over here we have a contradictory statement, that is services, or you can say set of services, do not actually define the process instance. Why? Because at runtime, right, suppose you have written logic like this: if condition is true, you will be calling service X. If condition is false, then you will be calling service Y, right? So can I say that I'm forming two set of services? One will be called if the condition is true, and the other will be called if the condition is false. Can I say like that? Right? So actually we are dividing the set of services in two parts. Okay, and that is why, that is the reason that at runtime, whatever service will be calling, right, that depends upon your logic. Okay, so we cannot say that all the services are part of my process instance. All the services are part of my process instance. I'll repeat this statement. We cannot say that all the services in one solution are part of my process instance, because process instance will be using only a few services at a time. Are you getting this or not? Is it clear? Yes? Okay. This is an important point to consider, right? Because this is an exception in the definition diagram. We'll soon see the diagram, right? Okay. So a process instance invokes a unique series of operations, right? So we say that process invokes service, right? So indirectly, can I say that process invokes operation inside a service? Yeah, indirectly, right? So that is written over here, right? A process instance invokes a unique series of operations to complete its automation, right? And that is why the last point is important. Every process instance is partially defined by the operations, right? Process instance is not defined by the service. It is partially defined by the operation. Why partially? Because it is indirectly related. Are you getting this or not? This last statement. I'll again reiterate two statements. Process instance may not be defined by the service, but it is partially defined by the operations. Why? Because ultimately you will be calling the operations, right? But are we going to call all operations? What is the answer to that? Yes, right? It depends on logic. We are not going to call all operations, and that is why we say it is partial definition. Okay, understood this point, right? Now I think we can go for the diagrams, right? Let me just switch the slide. Okay, so this, I have not labeled this diagram, but you can remember this is called interaction diagram. Okay, this is called interaction diagram of SOA components. Okay, so anywhere if you're asked, right, in the theory or in MCQ, that is what is interaction diagram of SOA components, this is the answer to that. Okay, fine. So let us start with the first one, process instances. Process instances, right? Why this is plural? Yes, that is my first question. Why we have not written process instance? As you know, process logic is written statically, right? But we might be executing more than one scenario on that logic. Yes or no? Correct, right? Many logics are there. So that is why they are multiple process instances, right? So process instances execute a series of operations. Okay, that is the right hand side. If you look at the left hand side, process instances compose services, right? You remember the composability principle, right? Composability means we are combining multiple services to achieve common goal, right? So for a given business task, you might require to compose multiple services, right? Okay. Then if you look at the bottom arrow, services logically group the operations, right? Services logically group the operations. Fine. Operations send and receive the messages. Okay. Operations send and receive the messages. So can you see a chain over here anywhere? In OS, we have studied that concept of process chaining, right? If anyone remembers that. Do you see any kind of chain over there? Over here? Where the chain starts and where it ends? At least tell me that. Chain means you are saying that one component is interacting with the other and the second is interacting with the third one and so on. Yes, correct. Correct. Process instance connects to the service. So we can say that process instance composes services. Services group the operations. Operations send and receive messages, right? So we have an extra arrow over here. Why? Because ultimately process instances will be invoking the operations, right? They will not be, you can say, invoking the services, right? They will be invoking the operations. So that is why then there is an extra interaction arrow present over here. Are you clear with this diagram? Okay, so in theory, if it is asked, you might have to draw this diagram and explain, right? The question can be, what is the interrelation between components of SOA, right? So you can draw this diagram and explain, right? That is the answer. Okay, in MCQ kind of questioning, you can be asked the interrelation terms, right? Which component matches with the other or links with the other. Okay, so just remember this. Okay, this diagram is important. If you remember the diagram, you can easily answer the questions, right? Okay, let us go for the definition diagram now. Now this is somewhat different. Why? Let us start with the first topic. Now we should start from top level or bottom level. If I say top level is process and the bottom level is message, so where we should begin reading this diagram? Yes, it has to be bottom level, right? So bottom level is message, right? So messages define operations. You can see the bottom arrow. Operations define services, right? Good up to this, right? But we have not drawn the arrow of services define process instances. Okay, I hope you are clear with the reason of that. Why that arrow is not present? Services and process instance, right? So this is actually not a complete chain. What is the reason? Can anyone reiterate why we have not said that services define process instance? Yes, correct, Prince. That is the absolutely complete answer, right? It depends upon the logic. So depending upon your logic, you will be calling 1, 2, or 4 services, right? Depending upon the if else or for loop, right? Whatever is written in your logic, right? But we can definitely say that operations partially define the process instance, right? Why it is partial? Because again, you will not be calling all the operations, you will be calling set of operations, right? But there is a relation. Okay, is this diagram clear? Okay, so many students have made this mistake in past, right? If you are asked to explain interaction between SOA components, then this should be the answer. If you are asked the definition diagram for SOA components, this is the answer. Okay, are you clear with the difference between these two diagrams? Right? The arrow directions are opposite, right? Actually, in this case, plus you need to label them correctly. Okay, fine. So we are done with the first topic of chapter number 8, where we have seen basics of SOA again, right, in detail. Fine. So this is the summary for that. Logical components of SOA, we have seen logical components of web services framework, right? And finally, we have seen components of SOA. Okay. Okay, so let us begin now. The remaining, you can say, discussion this week and the next week will be focusing on principles. First, our first topic would be what is the detail of each principle. Okay, we all know the terms: reusability, loose coupling, contract, right? But what is the effect of each principle on the architecture? That's what we will be discussing in detail, right? So that is the first topic going to be principles, right? Second topic would be which principle is related to which other principles, right? Because there is always a dependency, right? If I say that you want, let us say, reusability, right? So if you want reusability, is loose coupling required? What do you think? Even before we go for reusability, we require loose coupling, right? Because I can only reuse the service, right, if it is minimally coupled, right? If it is going to be connected in my solution, right, then I won't be able to reuse it. Okay. What about contract? Do we require contract for reusability? Do I need to search for a contract so that I can reuse the service? I hope you remember that contract is a WSDL, right? Basically, the minimum thing which we can say in contract is a WSDL, right? So like this, this is an interesting topic where we'll see interrelation between the principles. So that will be topic number 2, right? And then finally, we'll revisit the difference between service orientation and object orientation. Why I'm saying difference? Because each principle plays a different role in case of either service orientation or object orientation. So these three will be the topics which I'll be covering, right? And then we'll look at architectural styles of SOA. Before we end the syllabus, we'll look at the architectural styles. That is, how many layers of services which you can have, right? And in each layer, what type of services you will have, right? So after studying that, you will be able to understand and relate. Suppose you have implemented an employee service. So at which layer it should be, right? So application layers, that's what we'll be studying. Okay, that would be our last topic. Okay, so let us start. Let us just go through the definitions of principles once again, and then I'll take each principle at a time. Okay, and we'll go in detail. So services are reusable no matter what, whether you are designing the SOA for the first time from scratch, or whether you are developing a service above the legacy application, right? We have to focus on reusability, right? Because reusability will make sure that your service will be lasting for a long period of time. Okay, so we should look forward for potential reuse. So let us read the statement. Regardless of whether immediate reuse opportunities are there, right? That is, do we require reusability immediately or not? We should not think about that. From scratch, make sure that your services are reusable. Okay. To make services reusable, should the operations be reusable? It is just like class and method, right? You are doing in object-oriented programming. So if your operations are reusable, can I say that my service is reusable? We have just seen the interrelation, right? So can you answer that? Yes, right. Okay, so we'll see that kind of discussion as well later. Okay. Services share a formal contract. That is the second principle of SOA. Services share a formal contract. So we want that we should not be connected to the client all the time, right? Or we should neither be, uh, connected forever. Fine. So for that, what kind of mechanism we have obtained? We have gone for discovery mechanism, right? So before you want to consume a service, you have to get its contract, right? At bare minimum, you require the wisdom. Okay. So for services to interact, they do not need to share anything, but only one thing has to be shared, that is a formal contract. We all know what it describes. It has the list of operations and all those things. Okay. Third principle, we have said this from the first lecture onward, that is loosely coupled. Okay. This is the definition. Services must be designed to interact without need for tight and cross service dependencies, right? So basically, services should be dependent only for calling purpose. They should not dependent on each other for logic. Remember that statement which I said in the first or second lecture, I think, right? So by loose coupling, we mean that there should not be dependency of logic. Yes, you can call the services, but that is not a dependency. Clear with these three principles? Can we switch to the next slide? Yes, right. I'm just taking definitions right now, right? We'll go in detail of each principle. Okay. Next is services abstract underlying logic, or you can say that this is principle of abstraction, right? In general, what is going to be the benefit of abstraction? General question, right? You can consider this as an interview question. What is the benefit of abstraction? More simple to view. Yes, correct. Easy to use, easy to reuse, correct. Right. So basically, we want to hide the implementation technology, right? In terms of SOA, you can say that, right? We don't want to expose that in what language your code is written, right? And we expose the logic in such a way that everybody understands, like XML, or in the web API, you are using again JSON and XML format, right? I think you have explored that, right? Even in the lab. So basically, what we abstract is the underlying logic, right? Read the second statement. Underlying logic beyond what is expressed in the description. That means what we share is only contract, right? Everything else is hidden. Okay. So you can add one more thing to the advantage of abstraction: hiding the implementation technology. Yes or no? Can we add that? Hiding the implementation technology, right? So that we can show the generic interface outside. I'm extending the statement, right? Okay. Next, services are composable, right? So services can compose the other services. We have seen many frameworks, right? Coordination framework we have seen. Under that, we have seen atomic transaction, business activity, right? We also seen orchestration, right? In every case, we are composing multiple services. Okay. Let us go through the second statement. This allows the logic to be represented at different level of granularity, right? So what do you mean by granularity, right? I think I've explained this once in the class, right? If I say that your logic is coarse grain, that means you are combining multiple types of logic, or you can say multiple operations together, right? Or in terms of, let us say, a single operation, if the parameter that you are passing is an object is a complex type, right? And if you are passing a parameter as a primitive type, like as an integer or character, it is a simple type, right? So basically, If we use the principle of composability, we can have different level of granularity. That means if I'm composing 5 to 6 services, it can be called as a coarse grain composition. And if I'm only composing 2 services, it can be termed as a fine grain composition. Understood this term? Different level of granularity, what I've highlighted or underlined. Yes, is that fine? Okay. And it also promotes reusability, right? So if the service is composable, right, then it is going to be reusable. We'll see the relation as well at that point. This will be clear. Okay. And you can also create abstraction layers. Okay. So initially you will be composing upper layer services, and then you might be, if you required, you can go for the lower layer services. This term will be clear when we'll see the service layers, right? So again, composability is a very important principle, right, which will focus in detail. Okay, let us go for the next one. Services are autonomous, right? We have seen this many times. When I say that something is autonomous, that means it follows its own rules. Can I say that? Right? We have our own rule book and we follow that, right? That is what is autonomous, right? So in terms of service, yes, you can say that you have complete control over the logic, or you can say there is a boundary defined, right? Anything within that boundary is in your control, right? That's what we can say, right? So service has control within this boundary, and it is not dependent on any other service for it to execute. Okay. So that is less dependency. Okay. You might have a confusion. Then what is the difference between autonomy and loose coupling, right? Getting that kind of question in your mind? Might be tired as it has been a long day for you. But I think at least that question is coming up. Because autonomy is talking about loose you can say independence, and loose coupling is also talking about the same, right? So yes, it has to come, right? But we'll answer that, don't worry, right? I'm going to answer that question in, if not today, but maybe on Thursday, right? In the next class. Okay, so just remember that question. Okay. Services are stateless, right? Up till now, what we have said is services do not need to manage state. So then who manages the state? Yes, anyone remembers that basic concept? Correct. You have given the exact answer, Prince. It is soap header, and we can also say that the messages contain the state information, right? In other words. Okay. So services should not be required to manage state information, right? Because if you let the services maintain state information, then it will impede the ability, or it will reduce their ability to remain loosely coupled. All of you agree with this statement? If services become stateful, they will not be loosely coupled. Okay, as simple as that. Okay, this is one more point regarding relation between principles, right? As I said, that topic will be seeing in detail. Services should be designed to maximize statelessness, right? Even if, right, that means deferring the state management elsewhere. So basically, we are throwing up the burden on the message, right? That is written over here. So messages have to manage the state, right? Okay, clear with this slide? Autonomy, statelessness, right? How many principles we have seen? 3 plus 2 plus 2, that is 7. So how many left? Anyone remembers the count of the principles? Yes, it is 8 total, right? So discoverability, right? So services, it's good that you remember at least the number, right? We discussed, I think, this in the first lecture, right? There are 8 principles, and to fulfill those 8 principles, we'll be studying this subject, right? Okay. Can we say that if service is stateless, it is always achieving loose coupling? It will be incomplete statement. Loose coupling also requires autonomy, actually, right? or autonomy requires loose coupling, right? That all thing will be seeing, Urjit. I think in the next class, right? So we'll answer this completely over there, right? So this is a partial answer. We can say what you have said is correct, right? But it is not complete answer, right? So we have the set of diagrams which will see how principles depend on each other, right? That is going to be interesting again, right? So what my point is, don't mug these things up, because if you mug it up, everything will be mixed up, right? All 8 principles will be connected to each other, right? In your mind. Don't do that, right? Understand the concepts, then you can easily remember, right? Okay. So discoverability. Again, for this, I'll ask one more question like this, as Urjit has raised this point. If you want your service to be discoverable, do we require its service contract to be published? Yes. So can I say that discoverability requires contract principle to be fulfilled? Or you can say prerequisite kind of thing, right? Yes. So Urjit, are you getting this relation as well? So this is what I'm trying to point out. Every principle has some prerequisite, right? As well as some principle might be helping others. Like over here, we can say that contract is helping your service to become discoverable. I'll repeat, contract will be helping the service to be discoverable. Is that a correct statement? Right? So it can be vice versa also, right? So this is what we'll be seeing, right, in upcoming lectures, right? It may take time, but I'll make sure that you are clear, right? Yes, correct, Urjit. There can be cross connection, right? But see, the arrow direction would be where? Arrow direction will be from which principle to which principle in this case? Discoverability depends upon contract. Can I say that? Yes, right? Discoverability depends upon contract. Okay. So can I draw the vice versa arrow over here? No, right? It won't be possible, right? But we can form two statements. I hope, Urjit, you are getting my point, right? We can form two statements. One is contract helps us to achieve discoverability. Correct, right? Other is discoverability requires contract. Both are correct. I hope all of you are following, right? That's why I'm saying this is interesting, right? Because we have interrelation, right? So we'll see those diagrams, right, very soon. Today we might not be able to see, but tomorrow, not on Thursday, right? Not tomorrow. Okay. So there are 8 principles. Out of 8, 4 are critical principles, or you can say they are known as core principles, right? Why they are known as core principles? Because mostly these 4 principles help the others, right? And they depend upon very less number of principles. I'll repeat. They help many other principles, but they depend upon very few principles. Are you getting the statement? Right? On the if I try to create a table, dependency, right? So, and that table has 2 columns, right? One side is you are dependent upon, right? And the second side is you are helping which principles. Okay. So for these 4 principles, dependent upon column would be having less entries. Is that clear? Right? They depend upon less number of principles. That's why they are known as core principles. Which principles? We'll answer that soon. Okay. Fine. So autonomy, right? It's obvious that why it should be a core principle. It is independence, right, of your logic or control over the logic. Loose coupling has to be a core principle, right? We have been seeing this from first lecture. Abstraction, why it is a core principle? Can anyone tell me? Why it is a foundation principle of SOA? There is one point answer for this. Can anyone point out that? I think the first two are clear to you, but abstraction might form a doubt in your mind why it is a core principle. Okay, so let me answer that. Abstraction is core because we want to hide the logic and we want to correct it. Yes, and general. Yes. We want to hide the logic and we want to show the generic interface outside. And when we are sharing generic interface outside, contract also has to be a core principle. Yes or no? Because ultimately what you are sharing is contract. Agree to this, all of you? Right? So that is why these four are known as core principles, and the remaining four, which are left, discoverability, statelessness, composability, and reusability, right? They will be, you can say, more or less achieved if you achieve these four. That is the essence, right? Remaining four will be more or less. Why I'm saying more or less? Because we need to see the actual relation between principles, okay? But first goal of SOA architect should be we have to achieve these four. Okay, remaining four will come along, right? You can say that. Okay, so can you at least remember these four names for core principles, right? Yes, it would be easy. Fine. Okay. Let us start with the discussion on principles now. Let me begin with the first principle of the list. See, I'm not numbering the principles, and there is no actually relation or numberings between principles. I'm just going by the textbook. Okay. Thomas Earl has started with the reusability principle, so I'm going with the same principle, right? I'm not taking core principles first and then we'll go for non-core, right? Okay. So service orientation encourages reuse in all services, regardless of immediate requirements are there, right? So do we require to reuse this service immediately? Even if the answer is no, we focus on reusability aspect. Okay. Now for reusability or with reusability, what will be the benefits? We'll see them in the next bullet points. If you want to achieve reusability, application of design standards is required, right? Now, I gave you the example of design patterns, right? I think you remember that concept. Has anyone explored those patterns? Why they are known as patterns? Okay, let me give you a simple example. Suppose you are buying an adapter, right? And that adapter can convert any plug into the Indian plug. You might have seen that kind of plug, right? Right. So basically, that adapter is designed based on some standard. Yes or no? The circuit of that plug is designed based on some standard, right? So similarly, whenever you are designing a service, you have to follow some standard logic or standard way of programming, right? And that is known as application of design standard, right? Use a standard naming convention, use standard way of coding, right? That is called application of design standard. So if your code is totally customized, right? Will it be reusable? If your code is customized only for a specific situation, we can't term that as reusable, right? But if it is generic, we can say it is reusable. Yes, right? So that is the essence, right? We have to follow some standard way of programming, right? And that is why every company is training their employees, right? For, you can say, their own standards. You'll be doing that very soon. You are in 6th semester. After 1 year, you will be learning the design standards, right? Okay, so that is the first point. For reusability, make sure that you are following proper coding standards or design standards, right? Now, next comes the benefit. No need to create wrapper services if all the services, all is missing over here, are reusable, right? Do you agree with this statement? If you remember, wrapper service is something which is hiding the, you can say, logic which is divided in multiple types, or it is hiding the legacy. Remember that concept? Wrapper services are used to hide the inter relation, right? It can be a way of encapsulating, right? So if all these services are reusable, do we need to create a wrapper on top of that? What this basically means is, if your logic itself is generic, right, do we need extra layer of making them further generic? No, right? So in ideal situation, if this is ideal situation, right, because some services are going to be custom based, right? I agree to that. But in an ideal situation, if all the services are reusable, you require zero wrapper services. And what will be the benefit of having zero wrapper services? There will be less number of calls, because ideally, see, when you call a service, first your wrapper service will be called. That wrapper service will be calling the internal code which it is hiding, and then your reply will come. So there might be slight delay, right? Yes or no? We are having redirection kind of mechanism. Yes or no? So if we are having reusability, then wrapper services are not required. Okay. This principle facilitates all forms of reuse. So reuse has three types. This is an important point. Let us start with the last blue term, utility service. I hope you remember utility service. What is the example of utility service? Utility is a generic kind of service. It can be used in any scenario. Anyone remember that example? Correct, Dave. Load balancer, right? So this is one way of reusing, right? That is, I'm using the entire service irrespective of the scenario, right? The second example or second type of reusability is known as composition, right? Suppose account service is calling the vendor profile service, right? Once for checking the vendor details, right? And after some time, it again calls the vendor profile to check the another vendor, right? So can I say that it is reusing the vendor profile service for more than once? Can I say that account service is reusing the vendor profile service for more than one time? I hope you remember the case study, right? Yes or no? Okay, at least Deva has responded. What about others? Priyank, Prince, Surjit? Those who are replying at least? Yes. Okay. So, composition is another form of reuse. That is what I wanted to point out, right? When you are composing one service, that is, account is composing vendor profile. So I can say that I'm reusing that service. Okay. Let us look at the first term, inter-application interoperability. Right? It is not as complex as it is for reading, right? Interoperability means what? Independent of the architectural platform, right? Whether it is a .NET service or a Java service, I can call it, okay? And inter-application, that means you are invoking the service of the other application, right? There are two different architectures, architecture A, architecture B. You are calling the service on the other side, no matter what is its platform. That is also a form of reuse, right? Because that service has provided a generic interface, and that is why you are able to call that service, right? If it was not having a generic interface, can a .NET client invoke a Java-based service? No, right? So I think you are clear with this term. Inter-application, interoperability. Seems simple now, right? At least, okay, at least reply those who are replying, right? Okay, fine. So if you're asked, what are the three types of reusability, right? These three are the answers. Composition is one type of reusability. Having a complete utility service is a reusability aspect. And if you are invoking a service across the application and it is of different platform, then also it is reusable. Okay, fine. So this is one example, account service, right? If account service is providing three operations, get account, update account, and add account. Okay. So if I say that my account service is reusable, that means the operations also have to be reusable. Yes or no? Obviously, right? If my operations are custom, then my service won't be reusable, right? So there is a direct relation over here, and that statement is coming up, right? Last statement, which is mentioned in double quotes, the more generic a service's operations are, more reusable the service. Is this statement clear? I'll discuss the upper statement for next, right? I hope this statement is clear. Okay. Let us look at the first statement now. Messaging indirectly supports reusability through the SOAP headers, right? Why? Because we are writing the custom logic in the SOAP message, right? We are writing the navigation logic in the SOAP message. We are writing the exception handling logic in the SOAP message, right? So if we are embedding all this customization logic in the message itself, will the reusability of service increase? Yes or no? Will the reusability aspect of the service increase or not? Yes, right? So I hope this statement is clear. Messaging indirectly supports reusability because you are embedding all the custom information in the message. So that will make your service reusable. Okay, fine. So these two are important properties of reusability principle, right? If you're asked to explain these statements, you can write your the answer in your words. If you're asked in true, false, I think now you can answer. Okay, fine. Let us take one more principle, contract, right? Okay, reusability is a core principle or non-core principle? Before we go for the contract, reusability is core principle or non-core? It is a non-core principle, right? Because it depends on many other principles. We'll see that mostly tomorrow, right? Or on Thursday, sorry, right? Okay. So let us now take one core principle over here and we'll prove why it is a core principle. Okay. So service contract provides what? We already know this. Let us go through it. It provides the endpoint address, right, where the service is located. It provides the operations and their signatures, right? It provides the input and output messages supported by each operation, right? Or you can say the message exchange pattern as well. And it also provides the policy details, or you can say rules and characteristics. Fine. So basically, what we have covered over here in these four dash points, can you just relate to what we started this lecture with? What these 4 points are? The answer is there in the next bullet point. Yes, it is all primary components of SOA. Hence, can we say that it is a core principle? If it is covering everything which is required for SOA? This is one way of proving, right? We'll also prove in the other way in terms of dependency. But just remember this point, right? Contact is a very, very important principle. Okay, let us go for the details now. Fine. So a contract defines the service. A contract defines the operations that you can see in the middle tier. And the contract defines the messages, right? So these three things are defined by the contract plus the rules. Okay, or you can say the process itself. Okay, that is why it is known as a core principle. Okay, let us look at the properties. Contract design is extremely important, right? Because if your contract is not properly designed, it will affect the other principles. It will affect the discoverability. Yes or no? We have just answered that a few minutes ago. It will affect the reusability aspect. Yes or no? If you're not sharing all the operations, reusability might degrade, right? So what you expose, that you have to choose very, very critically, right? Okay, so contract design is extremely important, right? We have answered this statement. Let us go for the next one. Contracts need to be carefully maintained and versioned, right? So definitely, as the application evolves, there will be changes, right? And as changes will be accommodated, you will be modifying the visual files, right? But will you stop supporting the old clients which are using the old visuals? No, right? You have to continue support of your old clients also, right? So that is why contracts have to be properly maintained and versioned, right? So, or you will require a version control system, right, for maintaining the contracts. That is an important point. Visual definition, schemas, and policies can be viewed as communication contract. One more term we are learning over here. Because if I want to communicate with a service, I require three things. It's visual, the schema, because schema defines the data, and policies, because policies define the rule, right? So that's why it's known as communication contract, right? And this communication contract expresses how exactly the service can be accessed. Okay, fine. I'll just cover this slide and then we will stop, right? We'll continue with this in next lecture. The first statement is obvious. No one can predict how your IT environment is going to be evolving, right? If you want evolution to be supported, we require less dependency. Yes or no? If I want to accommodate changes easily, right, then I require less dependency. True or false, right? Okay. So being able to ultimately respond to unforeseen changes because we don't know, right, what may come, right, in efficient manner is a key goal of service ready. So actually this statement defines the goal of SOA as a whole. And which principle addresses this? It is only one principle, that is loose coupling. And that's why we said, and we have been saying this term in each and every class, right? So this is the actual definition. Having knowledge of other services, still remain independent. That's what we mean by loose coupling. Let us look at this diagram before we end. You are having two services, right? Services will be calling the operations, right? But their underlying logic is loosely coupled, right? So actually, this diagram is giving us two statements. Service A, although it is not written over here, service A is coupled to service B, but the code of service A is not coupled to service B. Okay. Is this statement clear before I take the question from Urjit? Yes, right? See, you are being dependent on the operation, but you are not being dependent on the logic, right? That's what I'm trying to say. So the logic is loosely coupled, but when you are remaining connected to that service for that period of time, you are coupled to the service B, right? Okay, let us now take the question from Urjit. If we compare contract versus policy, as contract is also stating some rules for us and policy is a part of contract, but still policy also defines the rules. Yes. So I think Urjit, you might have to check the definition. A service contract is a collection of four aspects. Remember that? Visual, schema, and what were the remaining two? Yes. So actually, policy is also attached with the contract. So actually, we cannot compare these two. Are you getting the point? There is no comparison possible because one includes the other. Are you getting? Right? Still, I'll clarify this in the next class, right? We don't have time right now. Okay, fine. Okay, okay. I'll just remember this and we'll continue with this question next time. Okay, and I'll continue with the next principles. Okay. Thank you. Let us end this session for today. Have a good day ahead.